Alright, angle notes. So, I believe you guys did IXL earlier this year, talked about different things in some of these terms, okay? Angles. So angles can be named by their vertex or by two non-collinear points in the vertex. So, a couple things. Well, what's a vertex? Well, the vertex is just the point, okay? So if I'm looking at this angle, CAD, what's the vertex? CA or D? Where's the point at? Point of the angle is where? Where? A. So A is our vertex. Okay? A is the vertex. So I can name this angle because there's only one angle there. I can say angle. Okay, that's our symbol for angle. Anytime we write an angle, we need to put the symbol A. And when we write these, they're always capital letters here. So angle A. The other way to name this is by two non-collinear points and the vertex. Well, what's non-collinear mean? Well, not on the same line, okay? So, non means not, co means kind of share, right? And then line. So, not on same line. So again, we have the vertex A. What other 2 points are not on the same line? C and D, right? So I can say angle, and again, you have to do this in the order, like if I'm tracing this angle, C, A, D. Okay? I can go in reverse order. So I can say angle DAC. So look, can I say CDA or ACD? Right? Can I say ACD? No, because it doesn't follow that line, right? So make sure when you're naming these angles, all you have to do is trace it. CAD, DAC, okay? Whatever one you want to name. All right, types of angles. Acute. Who can tell me what acute? Less than 90 degrees. Okay? So acute angles less than 90 degrees. You can sketch a little angle in there. Okay? Anything less than 90, let's say that is 67 degrees. Perfect. Okay? What's right angle? 90 degrees. Exactly 90 degrees. So equals 90 degrees. Now, there's a couple things in here. There has to be one of two things to tell you it's a right angle. It has to put 90 degrees in here just like I did on this angle. Okay, it's going to say 90. Or, most of the time you'll see this little box. It's usually red, unless it's on my paper for now. But if it's like a picture on the computer, a lot of times it's like a little red box. That means 90 degrees, okay? So when you see this box, that means it's 90 degree angle. It's a right angle. Obtuse. Obtuse is what?
More than 90.
Yeah, greater than 90. So greater than 90 degrees, and again, something similar to this, okay? So this angle here, let's say maybe 120 degrees. Again, 120, bigger than 90, it's greater than 90 degrees, okay? So it's an obtuse angle. straight. Yeah, 180 makes a straight line. Okay, straight line. That's a straight angle. So straight equals 180 degrees. Anything that has a straight line is 180. Okay, so it doesn't matter. If you see a straight line, 180 degrees. Doesn't have to tell you the actual angle. You can tell if it's straight or not. Adjacent. Okay. Adjacent only tells us one thing. Okay. So if I have an angle, let's sketch an angle here. So I have two angles. Okay, I have two angles. Actually, I'm going to redraw this line. So that sometimes it confuses. There we go. So I have two different angles here. And I'm going to number them 1 and 2. Okay, so angle 1, angle 2. Again, if they're numbered like this, you can use that as a naming. Okay, I can say angle 1, angle 2. A lot of times they won't be numbered, but for this example, it makes it easier. So angles 1 and 2 are adjacent. Okay, all that means is they're right next to each other. They're side by side. They share this green line, this green side. Okay, does that make sense? Doesn't tell me anything about the angle measure. It just tells me that they're right next to each other, that they share a side. Okay, that's it. Does that make sense? Okay. Letter F. Linear pair. What's pair? What's a pair mean? Yeah, two. Okay? Right? Pair of pants, you got 2 legs. Okay, pair of socks, you got 2 of them. Pair of shoes, you got 2 of them. Okay, so pair is 2. So linear pair, linear, what do you think linear means? Line. Okay, so linear pair, it's 2 angles that make a straight line. So what do I know about these 2 angles then? What do I know about this angle measure here? Again, if I label these angle 1 and angle 2, what do I know about angle 1 and angle 2 here? Well, they are on the same line. In this case, they're adjacent, right? They're next to each other. But more importantly, they're what? If it makes a straight line, it's what? It's a straight angle, which means it's 180. So these 2 angles together, right? So angle 1 plus angle 2 adds up to 180. That's what linear pair is going to tell us. Okay? Questions on that? So again, you can tell when it makes a straight line. Okay? So if it makes a straight line, you got a linear pair, 2 angles there. Those 2 angles add up to 180. Good. Next page. I'll get started on the next page. We're going to skip G. We'll come back to it. H, supplementary. Okay? Supplementary. Does anyone know what supplementary is? Okay. So supplementary, let's say here I have 3 angles, 1, 2, and 3. Okay. So looking at that picture, what do I know about these 3 angles? They're what? Okay, they're sharing a vertex here, right? But what else do they do? Yeah, they add up to 180 because again, these 3 angles together make a straight line, right? So angle 1 plus angle 2 plus angle 3 add up to 180 degrees. So, and that's why I put 3 on here. Okay, supplementary can be any number of angles. Okay, but it adds up to 180. So that's the big thing here. Adds up to equal 180. However many angles I have. Now, if I go back to linear pair, it's also supplementary. Okay, does that make sense? Linear pair is just 2 angles though. Supplementary can be more than 2. Okay, but it could just be 2. So linear pair and supplementary both 180. Okay, so let's go back here now to G. Complementary is what, do you think? Yeah. So supplementary adds up to 180, complementary adds up to 90 degrees. Okay? So I get 2 angles here. I have a 90-degree angle. Okay? Remember, it's going to have a little box in it. Okay? Or again, it's going to have actual angle measures in there. And I have another angle here. So now I have, let's say this is angle 1 and angle 2 again. So I know because of this red box that the green angle, right, is 90 degrees. So angle 1 plus angle 2 would have to equal 90 degrees. Okay? So angle 1 plus angle 2 equals 90. Okay? So complementary adds up to equal 90. Again, there can be more than 2 angles. Supplementary adds up to equal 180. And linear pair adds up to 180. Okay? Those are our 3 options right now. 180 or 90. There's really only 2. Okay? Last one here, angle bisector. Okay? Well, what's bisect mean? Yep, bi is 2, right? Bicycle, 2 tires. Okay? So bisector cuts it into 2 equal parts. Okay? So if I have an angle here, and again it can be any type of angle. And so let's put some letters on here. Okay. So this segment BC, okay? So we can say BC, segment BC, okay, or we can say ray, even if you want to be more specific, bisects angle ABD. Okay? So what that means is that ABC, so angle ABC is congruent to angle CBD. Angle C, oops, 2 angles in there. CBD. Okay? Representing that, they may put little arcs. Okay? So you may see a little arc. So see how these angles have the same arc? Okay? They can have one little arc, or a double arc, or a triple arc. Okay? Those arcs tell you that those 2 angles are congruent. Okay? So just like the little tick marks when we had lines, right? Remember how we had the bisect, where we had the line, and then it had little tick marks here and here, right? These little tick marks told us that each segment was equal, right? When this was bisected. Same thing here. These little, instead of little tick marks, they're just little arcs. Okay? Questions on those terms? I will at the end. Alright. Example 3 here. So, I don't know why this didn't print out. So that's those are angles. Okay? So angle ABC and angle CBD are complementary, which means what? add up to equal what? 90. Good. Find the measures of the angles. So these two angles add up to 90. So that's what I'm going to take. I'm going to take 12x minus 5 plus the other angle here, 7x, and it should equal 90 degrees. Okay? Now again, as you're doing it, if you want to skip this initial step, I know I'm adding these two. So if I want to add, so what's my first step in this equation? X's are on the same side, so what do I do with them? Combine like terms. Good. So 12x plus 7x gives me how many x's? 12 plus 7 is 19 x's. Okay? So again, if I want to do that, if I know I'm adding these two, I can go here, combine like terms. 12x, 7x, 19x. Then the minus 5 comes down. Okay? Still equals 9. Now what's my next step? Yep, get rid of the 5, so we're going to add 5. So 19x equals 95. Last step then is divide by 19. So 95 divided by 19 leaves me with x equals 5. Now are we done yet? Now remember, if we solve for a variable, what do we need to do with it? Plug it back in. Okay? So if I take 5, plug it back in here for ABC, right? I have 12 times 5 minus 5. Well, what's 12 times 5? 12 times 5, 60, minus 5, 55. So this angle here is 55 degrees. Okay? And then I can do the same thing with the other one. 7 times 5 is 35. This angle, 35. Again, when I add them up, 55 and 35 should give me 90, and it does. Okay. Questions on that? Complementary. Alright, number 4. Line FG. Well, here's line FG. FG. Okay. Bisects angle EFH. EFH. Okay. So EFH bisected. So you can see here. See how they have double markings? That tells me that they're the same. I didn't even need this statement, but bisect tells me that they're the same. They're marked with two little arcs, double arcs. Okay. So find the value of x and find the measure of EFH. So again, if it's bisected, they're equal, and that's my equation. 15x minus 15 equals 4x plus 40. Now my x's are on different sides, right? So complementary, supplementary, linear pair. X's are on the same side. I'm adding them together. Okay? Bisects, they're equal to each other, so they're on opposite sides. Everybody go with that? Okay, so how do I get my x's on the same side then? Subtract. Doesn't matter which one you want to subtract. I like the smaller one, so I'm going to subtract 4. So minus 4x on both sides. Whatever I do to one side, I have to do the other. So 15 minus 4 is 11x. Negative 15 comes down. 4 minus 4 is 0. Equals 40. Now what? Yep, add 15. So 11x comes down. 15 minus 15, 0. 40 plus 15, 55. And last step, divide by 11. So 11's become 1x, and x again is equal to 5. Again, we're halfway there. We got 5, right? Again, they're only going to have us solve for one because they're both the same, right? So EFH, EFH, so EFH is the big angle, right? Does that make sense? So EFH is this big angle. So I need to plug this in. I can plug it in one of them. It doesn't really matter which one I plug it in, right? I'm going to plug it in this bottom one here, the 4x plus 40. So 4 times 5 plus 40. So 4 plus 5 is 20. And then plus the 40. 20 plus 40 gives me the 60. So it tells me that this angle is 60 degrees. And this angle is going to be what? The same, right? They're equal, 60 degrees. So 60 plus 60 then equals what? Yeah. So these two together then, 120. So 120 degrees. Okay. So again, make sure, it's important, identify what angle you're looking for, because again, here they're both the same, so we solved it. When we plug these in, we have to add those two together to get the total. All right?